So in this video, I want to talk about the rank of a matrix a little more. I briefly mentioned the rank of a matrix when I talked about the row space and column space of a matrix, but now I kind of want to tie it all together. So for an arbitrary m by n matrix, the rank of this matrix is equal to the number of pivots in this matrix. So if we were to perform Gaussian elimination on this matrix and reduce it to its row echelon form, we would have a pivot right here, and everything below it would be zeros. And then we'd move on to the next pivot position, and we would continue this until what we have is an upper triangular matrix where our pivots are the first non-zero entries in each row. So since each column in each row can have a maximum of one pivot, then we can also say that the rank of a matrix is equal to the number of linearly independent columns and the number of linearly independent rows. But we have to recognize that the number of linearly independent columns and the number of linearly independent rows is the same thing as the dimension of the column space of A and the dimension of the row space of A. Or in other words, the rank of a matrix is equal to the number of basis vectors in the column space of A or the number of basis vectors in the row space of A. So let me demonstrate this concept with this example. If I have this matrix A, which is a 3 by 3 matrix, and I want to find the rank of this matrix, I can do so in multiple different ways. I can either find the number of pivots, I can find the number of basis vectors in the column space of A, or I can find the number of basis vectors in the row space of A. So let's go ahead and row reduce this matrix. So I have 3, 2, 1, 2, negative 1, 2, negative 4, 2, and negative 4. So I'm going to start off with this pivot position, and I'm going to eliminate everything below it. So I'm going to take the second row, and I'm going to subtract 2/3 times the first row. And I'm going to take the third row and subtract 1/3 times the first row. And this gives us the matrix 3, 2, negative 4, 0, negative 7/3, and 14/3. And in the bottom row, I get 0, and then I have 6/3 minus 2/3, which is 4/3. And then I have negative 12/3 plus 4/3, which is negative 8/3. And now I'm going to move on to the next pivot position, which is right here. So I'm going to take row 3, and I'm going to add 4/7 times row 2. And when I do this, I get the matrix 3, 2, negative 4, 0, negative 7/3, 14/3, 0, and then I have 4/3 plus a negative 4/3, which is 0, and then I have negative 8/3 plus 8/3, which is also 0. So this matrix is the row echelon form of A, and I'm going to rewrite this 3, 2, negative 4, 0, negative 7/3, 14/3, and 0, 0, 0. So this is the matrix that we can use to find the rank of A. The first thing that I want to point out is that these positions right here that I have underlined in blue are the pivot positions in this matrix. And these columns are the pivot columns. And then I could also circle the non-zero rows, which are these rows right here. So if you look at the basis for the row space, which are the vectors that I have circled in this light blue color, the row space of A is two-dimensional. And that's because there are two basis vectors in the row space. If we look at the basis for the column space of A, we see that we have two basis vectors for the column space of A. Therefore, the column space of A is also two-dimensional. And finally, if we look at the number of pivots, which I have in blue, then we can see that we have two pivots. So all this information means that we have a rank of our matrix equal to 2. And the reason for this is because there are 2 pivots. And as a consequence of having 2 pivots, the row space is 2-dimensional and the column space is 2-dimensional because we select our basis vectors for the row space and column space from the rows and columns that contain the pivots. So now we can kind of see how the rank of a matrix and its pivots are tied into the dimension of the row space and column space. So rows 1 and rows 2. Row 3 is made up of all zeros, therefore we don't pick